Okay, let's unpack this. Today we're taking a deep dive, not into poetry or romance novels about love, but really into the actual nuts and bolts. What's happening inside your brain?
Right, exactly. And we've got some really fascinating source material here. It's mostly research from Harvard Medical School looking at how love, affects our
The
biology.
circuits, the chemicals.
Yeah, the physical reality of it all.
And we're pulling from some leading experts, too. People like Dr. Richard Schwartz and Dr. Jacqueline Olds. They're both HMS professors, couples therapists.
Right.
And Dr. Helen Fisher, the biological anthropologist. Her work's been huge in this area.
Definitely. So our mission really is to get past let's say, the mushy stuff and understand the science. What's happening in your brain when you first fall? How does that whole biological landscape change over time?
And crucially, right, what does the research say about, keeping it alive long term?
Yeah, mapping the brain on love, essentially.
Okay, so where does it start? That first, wait, it's almost overwhelming sometimes, right? The rush, the infatuation.
Yeah.
It feels so unique, but the science points to a kind of common pattern, biologically speaking.
Absolutely. Dr. Helen Fisher's work is key here. She looked across, I think it was 166 different societies,
Wow.
and found evidence of romantic love, that really intense focus on one person in 147 of them.
So it's pretty much universal then.
It seems to be, yeah, deeply ingrained. People talk about being breathless, euphoric.
And she actually put people who were in love into brain scanners,
Eh,
fMRI machines.
She did, yeah. There was this one really telling study, college students all saying they were intensely in love. They measured their brain activity, looking at a photo of their partner versus just an acquaintance.
Okay, so what lit up? What parts of the brain got busy when they saw the person they loved?
Two main areas really stood out, the caudate nucleus and the ventral tegmental area, the VTA.
The VTA, hold on, isn't that like central command for the brain's reward system?
That's it, exactly. The VTA is, well, it's a critical piece of this really old reward circuit in the brain. It connects to places like the nucleus accumbens, the amygdala, hippocampus, the prefrontal cortex.
So all the big players in emotion and memory and decision making.
Right. And this whole system is just incredibly sensitive to pleasure, to reward signals. Think about things essential for survival, sex, food.
So the brain is basically treating early romantic love like a massive reward signal.
That's a core finding, yeah. And the main chemical messenger, the neurotransmitter driving this whole reward circuit activation, it's dopamine.
Ah, dopamine,
Mhm.
the famous feel-good chemical. Everyone talks about dopamine.
Well, it's more than just feel good. Dopamine is really strongly tied to focused attention, to motivation, and to craving, that drive you feel to go after rewards.
Okay.
So when you're falling in love, this surge of dopamine floods that reward pathway. It makes you focus intensely on that one person, and it motivates you, drives you to seek them out, be close to them.
Yeah. But falling in love,
Mm.
I mean, that doesn't always feel purely good, does it? There's anxiety there too, sometimes even like obsession. Is the biology explaining that part as well?
It absolutely does. So yeah, dopamine is high, but it's not the only thing going on. There's this whole chemical cocktail. The sources point to higher levels of cortisol, the stress hormone during early love.
Ah, okay. That makes sense.
Yeah, that contributes to the physical stuff, right? Racing heart, sweaty palms, that mix of really intense passion and anxiety.
Right. It really can feel like a bit of a beautiful crisis sometimes.
Totally. And adding to that complex picture, levels of another key neurotransmitter, serotonin, are actually low in these early stages.
Low serotonin. Okay, what does that do?
Well, this low serotonin is thought to be a big reason for the obsessive nature of infatuation. It's what Dr. Schwartz calls the intrusive, maddeningly preoccupying thoughts, hopes, terrors of early love.
Okay, wow. So that explains why you just can't stop thinking about them, can't focus. It's not just being emotional, it's tied to a specific, chemical imbalance, maybe similar to what you see in other conditions with obsessive thoughts.
Precisely. And the comparison they make in the sources is, well, it's pretty striking. Being love-struck, with that intense dopamine hit in the reward circuit, it actually shares similarities with the kind of pleasurable experience you get from substances like cocaine or alcohol.
Wow. Comparing intense love to cocaine or alcohol, I mean, that really underscores how powerful this biological reaction is.
It really does. And there's even some surprising evidence, connecting this reward-seeking stuff in the animal kingdom. A 2012 study in Science, kind of amazing, found that male fruit flies,
Fruit flies.
yeah, fruit flies, If they were sexually rejected, they then drank significantly more alcohol than the ones who'd successfully made it. It's like their brain was looking for another way to hit that reward pathway.
That's incredible. So, okay, we have this intense reward-driven state. It's fueled by dopamine, but it's complicated by stress hormones. And then low serotonin adds this obsessive element. What about the classic idea, love is blind? Does the science back that up?
It does, actually, quite directly. Romantic love seems to deactivate the neural pathways that are responsible for negative emotions, things like fear and social judgment.
Really?
Yeah, this pathway involves connections between the prefrontal cortex, your judgment center, and the amygdala, which handles fear and threat detection. When you're really deep in that romantic love state, the brain's machinery for making critical, even negative judgments about other people, well, it seems to be turned down.
Sure.
Dr. Schwartz actually called this the neural basis for that old saying, love is blind.
So your brain is literally less likely to see flaws or be critical. It's just laser focused on the reward and kind of ignoring the potential downsides.
That's the picture, yeah. Now, while that initial phase is super heavy on dopamine, other hormones start to become more important as the love evolves, particularly oxytocin and vasopressin.
Right. Those are the bonding hormones, aren't they?
Yeah.
Oxytocin, the love hormone or cuddle chemical.
That's them. Oxytocin and vasopressin, they play these really crucial roles in attachment, in pair bonding. Oxytocin gets released during intimacy, social connection. It fosters feelings of contentment, calmness, security. It deepens the bond.
Okay.
And vasopressin seems particularly linked to the kind of behaviors you see in long-term monogamous relationships, forming that stable peer bond.
So you start with this intense chase, the reward system firing like crazy with dopamine.
Yeah.
And then these other hormones, oxytocin and vasopressin, they sort of come to the forefront more.
That seems to be the shift, yes. And the sources explain that the difference in how these hormone systems work, compared to that initial dopamine craziness, helps explain why that frantic, passionate intensity often cools down a bit as the attachment grows stronger. The biological focus shifts, you could say, from getting the reward to keeping the bond.
Which makes sense.
Yeah.
And that brings us neatly to the next phase, lasting love, what's going on in the brain when love matures. Past that initial year or two when, as you said, a chemical roller coaster starts to settle.
Well, according to Dr. Schwartz, yeah, that initial flares of really intense emotion, the stress part of it, that generally subsides within about 1 or 2 years for most people.
Okay.
Cortisol levels, serotonin levels, they tend to go back to baseline.
Okay.
So the intense, sometimes anxious passion definitely decreases.
Right. So the fire kind of cools down a bit. Does that mean the brain's reward system just gets less active in these long-term relationships? Is the thrill gone, biologically speaking?
Not necessarily. This is really interesting. Mature love is often described as becoming more of a buffer against stress. But importantly, the brain areas tied to reward and pleasure, they do stay active in loving long-term relationships. Maybe the intense craving part lessens, but the reward signal itself, it's still there.
So maybe it's a different flavor of reward.
I'd say.
Less about the frantic chase, more about the steady comfort and connection.
The love certainly changes, yeah. It often shifts from that initial very passionate form to something deeper, more compassionate. But, and this is really remarkable, there was a 2011 study out of Stony Brook University. Dr. Fisher was involved again, looking at couples married for, on average, 21 years.
Wow. Over 2 decades together, what did their brains look like?
This is the amazing part. Their fMRI scans showed the exact same intensity of dopamine activity in those key reward areas. The VTA, the caudate nucleus, as they saw in people who were in the throes of intense, early-stage romantic love.
Wait, hang on. The same level of reward activation after 20-plus years? That kind of blows up the whole idea that passionate love just inevitably fades away into comfy slippers.
It certainly challenges that notion. It suggests that the excitement, that intense reward feeling associated with romance, it can actually stick around in long-term relationships. Yeah. Even when the initial anxiety and stress and, the obsessive bit are long gone, It basically says it's biologically possible to still feel that intense spark decades down the line.
That's incredibly hopeful, actually. But, okay, what about couples where maybe that initial spark has genuinely faded, where things feel more routine? Is there a biological angle to losing that intense reward feeling over time?
Well, the sources do suggest that couples can sort of get out of the habit of doing the things that stimulate those romantic reward pathways. Life gets busy,
Yeah, routine sets in.
But they also suggest that this connection, this spark, can be reignited through good reasons or actions, as they put it.
Like consciously making an effort. Date nights, focus time together, that kind of thing.
Exactly. And they specifically mention sexual activity as a really key example. Sex obviously increases oxytocin, which deepens the bond,
Right.
but it also directly activates the brain's reward circuit. So engaging in that can actually help couples desire each other more, potentially re-engaging those same dopamine pathways linked to pleasure and pursuit, but now within this secure long-term context.
Interesting. So the science really does support the idea that making an effort, doing specific things together, can actually stimulate the biological systems that underlie that romantic connection.
It seems so, yeah. The potential is there.
Wow, this has been quite a journey.
Uh,
From that breathless, almost overwhelming rush of infatuation driven by dopamine, cortisol, low serotonin, then shifting towards the bonding hormones like oxytocin, vasopressin,
right.
and ending up with a surprising potential for really intense reward activation. That same dopamine hit, even in very long-lasting love.
Yeah, we've seen how the whole chemical landscape sort of evolves, but
Yeah.
that core reward system in the brain, the very same one that lights up like crazy in early love, can stay highly active deep into committed relationships. It's not just about companionship. The potential for real romantic intensity seems to persist biologically.
Which is a pretty powerful thought. So I guess the question for you, listening, is, given all this biological insight, that love involves these specific chemical pathways, these reward circuits, stress responses that change over time, and maybe can even be stimulated by what we do.
Yeah.
What does that change about how you think about love or commitment? Or maybe the effort involved in nurturing a long-term relationship? Is that enduring passion just pure luck? Or does this biology suggest there's a real basis for why making an intentional effort actually matters? Something to think about.